A LabVIEW program is called VI, short for Virtual Instrument. Each VI consists of three main components: the front panel, the block diagram, and the icon and connector pane. The front panel serves as the user interface, allowing users to control and view data. The block diagram is the programming workspace where functional blocks are connected to define how the program operates. The icon is a small graphic that visually represents the VI. When the VI is used as a sub-VI within another block diagram, this icon appears as its symbol. The connector pane is a layer overlaid on the icon that divides it into terminals representing the VI's inputs and outputs. Each connector is linked to a control or indicator on the front panel. When a wire is connected to a connector, the data carried by the wire becomes either the input to the corresponding control or the output from the associated indicator of the sub-VI. The LabVIEW front panel serves as the graphical user interface of a LabVIEW program. It contains controls for inputting data into the VI and indicators for displaying the output results. Examples of controls include knobs, dials, sliders, numeric inputs, buttons, and switches. Examples of indicators include graphs, charts, LEDs, meters, and numeric or string displays. The controls and indicators on the front panel can be freely arranged, resized, and customized in appearance, including color and style, to create a clear and user-friendly interface. This is the execution toolbar, which allows you to start, pause, or stop the VI. This option sets the font for the front panel. These tools are used to align objects on the front panel. This search tool uses the AI feature from an eye. This question mark turns on or off the context help feature. Control palette contains controls and indicators for the front panel. You can access the control palette by selecting View, Controls Palette, or right-click on the front panel. This is the numeric subpalette. Here are the numeric controls and numeric indicators. Here are the knob and dial for numeric input. Here are the gauge, tank, and thermometer indicators. This is the Boolean subpalette. You can find push button, toggle switch, LED, and OK button. This is the string and path subpalette. You can find the string control and indicator, and file path control for file name input. This is the graph and chart subpalette. You can find indicators like waveform graph and waveform chart. LabVIEW controls and indicators come in various styles, organized into different subpalettes. You can choose from 5 styles: Modern, Fuse Design System, Silver, System, and Classic. The System subpalette provides objects that automatically match your operating system. Their appearance changes depending on the platform where the VI is running. For example, controls may display different colors and styles on Linux compared to Windows, ensuring they align with the native look of the operating system. The LabVIEW block diagram is where graphic programming code is created in LabVIEW. Terminals on the block diagram represent the controls and indicators found on the front panel. Double-clicking a terminal highlights its associated control or indicator, and conversely, double-clicking a control or indicator on the front panel locates its corresponding terminal on the block diagram. The value entered into a control is available at its terminal, and any new value sent to a terminal is displayed in the associated indicator. The block diagram toolbar contains several important controls. These include buttons to run, stop, or pause a VI, as well as the Run Continuously button, which repeatedly executes the VI after each completion. Note that if an error occurs during execution after hitting this button, the Stop button may become inaccessible, preventing you from manually stopping the VI. The toolbar also includes debugging tools. The Highlight Execution button, represented by a light bulb, visualizes the flow of data through the wires. Animated bubbles travel along the wires to show the execution sequence, significantly slowing down the VI, so you can observe how data moves through the code. Another useful debugging tool is the Retain Wire Values button. When enabled, it allows you to use the probe tool to view the value on a wire immediately, without waiting for the program to reach that point again during execution. Additional buttons are available for step execution, which let you run the VI one step at a time. These features will be discussed in detail in the debugging section. You can also use the toolbar to set the font on the block diagram and align objects for a clean, organized layout. In LabVIEW, programs do not use traditional variables. Instead, they use wires to transfer data between nodes. The color of a wire indicates the data type. For example, orange represents floating point data, blue represents integers, pink represents strings, and green represents Boolean values. The thickness of the wire indicates whether the data is a scalar or an array. A thin wire represents a scalar value. A thick wire represents a one-dimensional array, and a double line indicates a two- or multi-dimensional array. LabVIEW nodes are objects on the block diagram that have inputs and/or outputs and perform operations when the VI runs. Nodes can represent functions, sub-VIs, or structures, such as case structures and loops, which provide logical and control flow within the program. The LabVIEW block diagram includes a functions palette that contains programming structures, functions, and VIs. You can access the functions palette by selecting View, Functions Palette, or by right-clicking anywhere on the block diagram. The first section in the functions palette is the programming palette, which includes several subpalettes. This is the structures subpalette. It contains loop structures, case structures, and event structures. This is the numeric subpalette. It includes arithmetic operators, mathematical functions, and numeric constants. This is the comparison subpalette. It provides relational operators and comparison functions. This is the array subpalette. It contains array-related functions such as index array and replace subset. This is the Boolean subpalette. It includes logic functions and Boolean constants. This is the cluster subpalette. It provides cluster functions. Cluster in LabVIEW is equivalent to a structure in C or MATLAB. This is the string subpalette. It contains string manipulation functions such as search, replace, and match operations. If you need to use a user-defined sub-VI, you can select and load the VI file onto the block diagram. Here is the summary. LabVIEW is a graphical programming language composed of three main components: the front panel, block diagram, an icon, and connector pane. The front panel serves as the graphical user interface of a LabVIEW program. Controls act as the inputs, while indicators display the outputs. You can access various controls and indicators from the controls palette. The block diagram contains the graphical code of the program. The controls and indicators from the front panel appear as terminals on the block diagram. You can build your program using structures, functions, and sub-VIs available in the functions palette. Wires on the block diagram are used to connect elements and transfer data within the program. Thanks for watching. If this tutorial helped you, don't forget to like, share, and subscribe for more.